Okay, so let's say you've got a polynomial, and you've checked to see if it's a difference of squares, you've checked to see that it's a perfect square trinomial, you even checked to see if there's a greatest common factor, and you've come up empty-handed. You might think you're out of luck. Well, you'd be wrong as you could possibly be. Wrong. There are plenty of ways to factor polynomials. Today, let's focus on quadratics. We've been studying quadratics in class, right? So you probably know by now that quadratics usually look something like this. Something times x squared plus something else times x plus some other number. Here is a quadratic. X squared plus 9x plus 14. It just so happens that quadratics are super easy to factor, especially when the leading coefficient, that means the coefficient of the very first term, is a 1, just like this one. Here's how you do it. Step 1. Look at the last term and break it down into as many pairs of factors as possible. Here the last term is 14. So let's break it down into pairs of factors. 14 could be represented as 1 times 14 or 2 times 7. Easy peasy? Step 2. Look for a pair of factors that add up to the coefficient of the second term. Here the second term is 9. Well, 1 and 14 add up to 15, and 2 and 7 add up to 9. So it looks like this is the pair of factors that we're looking for. Step 3. Place those factors into two binomials with the variable. That sounds a little confusing. Let me show you what I mean. We're going to take these two factors and put them into two binomials. Inside those binomials, though, we will also have the variable of the trinomial, which in this case is x. So this is going to be x plus 2 and x plus 7. And that's it. This is the factorization of this trinomial. Now, don't believe me? Well, do the distribution yourself. Pretty simple. We're going to get x squared plus 7x plus 2x plus 14. Combining like terms, we get x squared plus 9x plus 14. Oh, I guess you didn't have to do that yourself. Anyway, let's practice on another one. X squared minus x minus 12. So let's start with the last term and break it apart into as many pairs of factors as we can. We could have 1 times 12, we could have 2 times 6, and we could also have 3 times 4. But now wait a minute. This is a negative 12, not a positive 12. So that means we could have a negative 1 times 12, a negative 2 times 6, a negative 3 times 4, but we could also have a positive 1 times a negative 12, a positive 2 times a negative 6, and a positive 3 times a negative 4. Good so far? Now we're going to look for a pair of factors that when you add them together, they sum to a negative 1. Okay, negative 1 plus 12 is 11, negative 2 plus 6 is 4, negative 3 plus 4 is a positive 1. Well, we're pretty close. What if we flip the sign? A positive 3 and a negative 4? Well, that's negative 1. So right there is our pair of factors that we're looking for. Pop those into some binomials, and we have x plus 3, x minus 4. This is the complete factorization of this trinomial. That's all there is to it. We should also remember that, as always, it's sometimes necessary to factor out a greatest common factor before we can use this factoring method, like here, negative 3x cubed plus 3x squared plus 36x. It looks like we've got a greatest common factor of 3x. Also, this first term has a negative sign in front of it, so we should probably factor out that negative sign as well. So let's rewrite it with a negative 3x on the outside. Left over inside, we'll be left with an x squared minus x minus 12. And this is indeed a quadratic, and the leading coefficient is a 1. So let's use the method we've been using. Let's look at this negative 12 and break it down into pairs of factors. We'll have negative 1 and a 12. We'll have a negative 2 and a 6. We'll have a negative 3 and a 4. We'll also have a positive 1 and a negative 12, positive 2 and negative 6, and a positive 3 and negative 4. And we're looking for a negative 1 just like last time, and it looks like this pair of factors right here add together to become negative 1. So that means the complete factorization of this trinomial will be negative 3x on the outside times two binomials that are x plus 3 and x minus 4. Feeling good so far? Because I've got some good news for you. We can also use this method to factor some trinomials that are not quadratics. Like this one. X to the 6 plus 2x cubed minus 15. Well, now this trinomial is most definitely not a quadratic, but it shares some important qualities with quadratics. Most importantly, the degree of the first term is twice the degree of the second term. So if we wanted, we could use the power rule to rewrite it like this. X cubed to the second power plus 2 times x cubed to the first power minus 15. Now does it look a little more like a quadratic? Some people like to go a step further and use an advanced technique called a dummy variable. Using a dummy variable is kind of like using a predator drone to solve a math problem. One of the numbers is going to stay at home and send out a remote-controlled fighting machine to solve the problem in its place. So in this problem, the number x cubed could stay back at home and send out a different, more simple variable in its place, like z. So we're going to say x cubed equals z. Now we can rewrite the problem, replacing all of the x cubes with z's, and it'll look like this. Z squared plus 2z minus 15. Well, now that looks exactly like a quadratic. In fact, it is a quadratic, and we can solve it exactly like a quadratic. Let's look at the last term. It's a negative 15. So we could have negative 1 times positive 15, negative 3 times positive 5, positive 1 times negative 15, and positive 3 times negative 5. We're looking for a pair of factors that add up to positive 2. Well, that would be a positive 5 and a negative 3 like that. So let's throw those into some binomials with the variable z, and we will have z minus 3 times z plus 5. Well, now we've factored the quadratic successfully, but that x cubed doesn't want to stay at home anymore and let his predator drone dummy variable take credit for all of its work. It wants to show up to the award ceremony and receive its Medal of Honor. So, as a last step, all we need to do is go back and replace all of the dummy variables with x cubed. X cubed minus 3 times x cubed plus 5. Easy peasy. Okay, so now we've come to the end of the video. To thank you for making it this far, I'm going to offer you a challenge. I'll tack on an extra credit percentage point to anyone's grade that can show me how to factor this. X to the 4th y squared plus 4x squared yz minus 32z squared. It looks a bit ugly, and you'll notice that the third term here has a variable, but it can be factored exactly the same way as a quadratic. Good luck, angels. Charlie out.